Hi, so my name is Cody Rogers, and today we are going to go through the update I did to my dusk to dawn, like light on when light says off circuit that I initially did using solely a differential amplifier, a bunch of discrete transistors. I changed it to have this just a single op amp, a comparator. So we're gonna start by going over the schematic, and then after going over the schematic, while in the schematic, I'll realize that I should have done this, put these test points at a different place for the PPK2. So we will change that, and then we will actually go in and we will redo the layout basically. So stay tuned in, and I hope you have fun. Let's go to the schematic. Right now, I just want to go over my Dusk to Dawn update. I'm using the TLC 372CP comparator instead of the differential amplifier that I had been using before. So we're still going to use a 3-volt battery cell. I'll show you though. Here I'll show you maybe first. I'm actually planning to use this one instead of the one that connects to the board itself. And there's a few reasons for that. One, it would be easier to sort of move into a place which then can be used, like easily accessible by a user in my Christmas light idea. And three, it has its own on-off switch. And then it also takes up less room on the board. So that's this one here. Then this is again a test port for the PPK2. This is just to signify that this is 3 volts for when I go do the layout. I can change the track width and such. And then down here is what's most important. So this is set at 33K to match this photo resistor here at its like decision point, we'll call it. So when this is less than 33K, that means that the voltage seen here will be higher than the voltage seen here, which will result in basically nothing happening. This will be outputting a higher voltage, so it will stop the LED from turning on. Now, when this is at a higher resistance, so it's dark out, that means that this voltage here will be, wait a second, it's dark, yes, this voltage here will be less than, or more than, less than the voltage over here. I always get so confused with that. So when this voltage right here is less than the voltage over here, well then that means this is going to be like, that's not right, and it's going to swing to its negative rail, which happens to be ground. So this will just start sinking current. And then I put in a small capacitor here to a cleaner output, or a cleaner voltage rail. And then of course we have a test port here, a test port here. Oh, I should have put test ports there. Okay, well, we'll have to add that here now. But we also have a test port here too. I wonder, I don't really think we need these two test ports. How about let's move this up here. view up here. Now, we're going to have to go to the PCB layout, but we are going to have to redo it a bit. And so what we will do here, just going to delete this, and then we will go up here, go edit, global deletions, tracks and vias, okay. So now, I'm just going to pull up the schematic so I can see that as well at the same time. So that goes to the way the photoresistor is, this one. Oops. Let's just move this guy over here. This one we will move here. This one. That. Might as well actually move this one like that too. You can also take this down so I can get finer movements here. Three. In 3. This down like that. Like this. Just gonna that invisible. So now we can move this over here. That. Can probably move that circle over. Just put this back to the 1 millimeter thin spacing. There. So now it's just like everybody else. Okay. Sorry, I'm just thinking here. I'm thinking if I go here, rotate this. Go and we will make this like that. This up like that. Now I'm just sort of fiddling with the layout some. Now that I fixed the main problem that happened. I'm just gonna see if I can make things a little bit better. You see, now this should flow much better. And then this capacitor actually gets much closer to its ground, which is good too. So, yeah, this will work a lot better. Oh yeah. Okay, so let's start this front copper layer. We're just gonna wire up these here. And then that can go there. Then you see we can keep all of this on the front copper layer, which before we didn't, because we were basically overstepping on the back layer and it, yeah. I'm actually gonna make this, it's not that one, this one. Gonna make it a little bit larger. So that everything flows nice, hopefully. Yeah, the next ones we can do are you. So now we'll do the fills. The filled zones. Actually, I can't. We'll first do this ground one here. Let's just add a couple. Let's actually do a whole filled zone right there. A mini filled zone. And then that just, it will give this capacitor a nice connection, hopefully. So let's go there. Now, I'm going to do another filled zone. This time on the 3-volt net. That's not what we want. Now let's pull it in. Okay, I think that looks okay. Now let's do the ground plane. Switch to that one. Oh, I did forget this. And we also special change that to 1. This, I like having a nice solid connection there too. Okay, let's go here. Ground. And we will fill that one. Yeah, just to get that third one in. Yes, so now I think we are good. And I guess I've covered most of the things that I was concerned about. Because I had to redraw the board. So, let's just run a design rules check. Okay, it's good. Let's look at it in the 3D viewer. Nothing seems too terrible there. This does look a little bit odd, but I'll get over it. We could make this trace bigger, I guess. in general the trace is bigger. But I think it will be fine. So let's exit out. Save. So I hope everybody liked that video. Stay tuned for the video where I will be evaluating. So we'll go in and we'll use the PPK2 to look at those test boards, see how much current is going through them. And yeah, that will probably be it. I'll also probably be doing a live soldering video if you like that. I think most people use them just as background noise. I'm not actually sure why. But anyways, be sure to tune in to the future videos, including the evaluation video, and any other videos like my power supply, all those. Let me know what you think in the comments, and if you really like this content, subscribe and like it. Thank you.